the Shapadi protection, where we talked about protection level 1, protection level 2, and then we also spoke about input validation. Number patwala the Shapadi sequence control. We won't even talk about your emergency stop shan yuko, your shan flow because we know we classified those as either protection level 1 or protection level 2. That's going to come up later. Okay, so number to help us with the sequence, the key elements of the sequence are maybe things like the system stop, system start, and then of course we're talking about the 3 position selector switch, normal select, off position, test select. Okay, I think those are the user interactions that we need to come across. So this is for the crusher lubrication. And then for the main drive, crusher main drive, the user interaction would be just the normal select. Okay, the normal select, and then the test mode, main drive mode. Okay, this push button is basically for you when you're doing the testing of the main drive. Okay, and then similarly the same thing goes for the test mode loop pump motor, this one. So we've got this position, the test mode loop pump motor, the push button, then the 3 position selector switch, then the system start, the system stop. We already have the start stop, so we're covered when we talk about the system start, the stop as start, stop, and then what else do we need? We need the 3 position selector switch. So operators, is it on operators or items? So let's check. Okay, operators, this is the selector switch. Put it at the very end in that position. Because I know for a fact that we're going to need 2 of these. Okay, we're going to need 2 of these, so this we can put there. Okay, so what do we have to do with this one here? Selector state, do we get a 3 position? Configuration, we need a 3 position. Okay, and then state 1 is going to be normal. Okay, so this is the loop. Okay, loop pump normal. Okay, normal select, like so. So we've got the loop pump normal select. Oh, what did we do with the, I'm talking about the mapping, input to output mapping. What were we saying? Loop pump normal select, loop pump test select, loop pump normal select. So this is what we're doing. So let's maybe borrow the same. Come on. Okay, so loop pump normal select. I'm just trying to maintain the labeling. Okay, so that we directly relate this. Okay, so loop pump normal select. Okay, then loop pump test select. Okay, so this one here, loop pump test select with this one here. So that takes care of the loop pump. Then test mode push button, so loop pump test push button. Okay, let me just push this a bit down. Then so this level, the next line, we just have to do with the loop pump. Okay, so loop pump normal select, loop pump test select. Okay, Then we'll need the loop pump test push button. Okay, so loop pump test push button, to get this here. Then test, we can use the same color. Like so. So this is going to be loop pump test push button. Okay, and then right after that we talk about the main drive. Okay, so we talk about the main drive. So state 1 will be the main drive normal select. Okay, will be the main drive main select, and then in this other state will be the main drive test select. Okay, main drive test select, like so. Oh, come on, forgot one teeny thing. This is supposed to be 3 position. Okay, supposed to be 3 position. How could I not have seen that? Main drive normal select. Okay, this one here, and then this other state is main drive test select. Okay, main drive test select. So that takes care of that. And then the main drive test push button. So we'll just borrow this. So this is going to be push button. Okay, this is going to be the main drive test push button. Okay, like so. We get that. Press there. So we don't need this. So this is what we have. I know it looks messy, but once we push this off, we're going to have a very clear view of what it is we're trying to do, what it is we're trying to accomplish. So 3 position selector switch, position 1, loop pump normal select as a peripheral input, loop pump test select as a peripheral input, then this push button here, the lubrication pump test push button as a peripheral input. These are just representations of this. Okay, this 3 position selector switch is this one here. Okay, for the loop pump was that thing. This is the loop pump here. Okay, this is the loop pump, and this 3 position selector switch is this one here. Okay, this push button here is this push button here. So the same thing for the main drive. Okay, when you talk about the main drive, this 3 position selector switch is this 3 position selector switch. This test mode main drive motor, the push button here is this push button here. Okay, so basically that takes care of the interface for the sequence. Okay, if we have we've made some errors and omissions, we'll come and take care of that later, but for now I think this pretty much seals it. Okay, maybe the only other thing that we may need to take care of is the issue of flow. Okay, because when we're doing the mapping, so flow, flow, what did we say about flow? It wasn't mapped to anything. Flow just stuck out as flow. Okay, flow 01. Okay, these were not passed on to anything. These just came in as flow 5.7 and 6.0. I get to configuration is alternate action. Okay, so maybe we'll borrow this reset. Okay, borrow this. Okay, then we're going to copy this same one, and then of course let's bring on the sensor tags. Okay, but this one here we're going to say flow. Okay, we're going to copy this. This is the one I'm talking about. We're going to copy this tag here and then paste it right about there. And then for this other one is flow 0201. Okay, let's take that, paste here, and then we're going to choose alternate action. Okay, same thing goes for this other one, alternate action. Okay, so that takes care of that. What is happening here? Or was I actuate tags? Reset. Thought we changed this. Why are you not changing? Okay, so flow 02. Okay. And that takes care of that. So flow 0101 and flow 0201. Okay. So we have these. So ideally, we said 01 is a designation for a normally open auxiliary contact for the field device. So we're just using these reset push buttons to just give us the simulation interface, because the reset, as we initially saw, was wired as normally open. Okay, so to help us fully grasp the effect of that, so maybe let me minimize this a bit. Okay, because our key focus is just on the behavior of the flow. Okay, but before that, 5.7 and 6.0. Okay, for the flow. So we're interested in 5.7 and 6.0 as addresses. So drivers 5.7, 6.0. Okay, so 5.7, 6.0. We need flow 01 and flow 02. So 5.7 and 6.0. Okay, that takes care of that. So let's look at that behavior. Okay, let's take this on. Can we monitor this? Okay, so in relation to the flow, we're interested in this part here. Okay, where it says status, we need to check the signal state of flow 0101 and flow 0202. So if I did this, okay, you notice that it changes to 1, a true state of 1. Okay, and then I need to press it to reset. I need to press this other one to set this. I need to press to reset. Okay, so basically that maps the input signal for the flow. Okay, and then what else do we need? The other thing we need is the multi-position selector switch. Okay, so the multi-position selector switch, we're talking about loop bump normal select. Anyway, we can just look at the first section. Okay, so where it says loop bump normal select is input 1.3. Okay, so loop bump normal select, loop bump, this one here. Okay, This one, loop pump normal select is input 1.3. So loop pump normal select, loop pump normal select is input 1.3, like so. And then loop pump test select is 1.5. Okay, loop pump test select, loop pump test select is 1.5. And then main drive, okay, loop pump test select, loop pump normal select, then the loop pump test push button. The loop pump test push button is 1.6. okay, so loop pump test push button, where are you? Loop pump test push button, loop pump test push button, which is this one here, is 1.6. okay, so loop pump test push button is input 1.6. loop pump test push button is input 1.6. Then the main drive, normal select is input 2.0. main drive normal select, main drive normal select is input 2.0. then main drive test select is input 2.2. so main drive test select is input 2.2. main drive test push button is input 2.3. main drive test push button is input 2.3. I think that pretty much takes care of everything. Okay, so we can save this. Okay, we need to stop the system, then we need to save, like so. Okay, so our interest is in the 3 position selector switch. So loop pump normal select is basically 0, and then the loop pump test select, the status is 0, or false if you want. So loop pump normal select in this position, so loop pump normal select is position 1, so it becomes true. And then loop pump test select is false state, true state. Okay, this one here. And then the loop pump test push button, so loop pump test push button, which is in this state right now, the status is false or 0 if you want. Now it's true. Okay, so this is okay. And then the main drive normal select, so if we come here, we need to see this. So main drive normal select input 2.0. so main drive normal select, that's okay. And then main drive test select, okay, which is fine also. And then the main drive test push button, which is also okay, right? So now we see that we've basically mapped the inputs. Okay, the inputs that we're going to need to simulate the conveyor, or rather sorry, the crusher. It's like we've done a lot of conveyor logic design, so just kind of stuck with me. So mamwana ukutila ati all the inputs that we need to simulate our logic have been wired in. We just insert an object which we are going to call, okay, I just call it a function. We're going to call this as sequence. Okay, we're going to call this as sequence control. So this here function is just sequence control. We just say okay, and then function 7, as always, we need to have it called in OB1. Okay, so insert a network, view overviews, then we go to where it says functions. We got function 7. Always a good idea to save. Then code block, open. Now we have this, what we need. Okay, so in as far as sequence is concerned, okay, don't worry about all this. Sequence just means how does this system start. Okay, so what we're going to do now is we're going to start from network, or rather rank 4. Okay, So in this run, we are not going to concern ourselves with 3BD5, 283, 3BD3, but we're going to talk about 3BD4, right? We're going to talk about 3BD4, and then we're going to talk about 4DD2. And then of course, we're not going to talk about 3BD6 or 4DD1, but rather just a system stop, system start. So this is what we're going to do. We're going to create an O branch, okay? We're going to create an O branch like this, of which we're here, right? And then we're going to say 3BD4. We're going to say 3BD4, and then we're going to say 4DD2. Okay? We're going to say 4DD2, and then of course we're done with this. Okay, we're not going to concern ourselves with 3BD6, because if you look at this, 3BD5, 283, 3BD3, 3BD6, 4DD1 were either level 1 protection or protection level 2. So it's just as well we just say Control Z. We just say this. We just do this, okay? So we can just as well say protection level 1, okay? Then protection level 2, okay? So protection level 1 or protection level 2 accounts for either 3BD5, 283, 3BD3, 3BD6, 4DD1 as earlier discussed, okay? So now the only thing we need to come and pay attention to is the system stop. Externally, it's wired through a normally closed contact, okay? So what we're going to do is we wire it internally as normally open, and then of course this is going to be just stop, 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 system stop if you want. Okay, it's going to be system stop, which takes care of this, and then thereafter, no, I don't want that. Thereafter we're going to have we're going to have a system start, okay? We're going to have system start. We're going to have system start. We're going to have a system start, and then thereafter we're going to have 3BD1. Okay, so we need an output coil, then place ourselves with 3BD1, like so. And then we need an O path across this one here, like so. This is basically just a saline contact, okay? But again, when you talk about anyway, it's not neither here nor there, so it's fine. So this is basically just a saline contact. So what do we have here? Okay, this is fine. So is there any way we can simplify this, make it look a little bit more agreeable? So this is alternate, and then when you come down here, you press the system start, you sell in through that. At that point you either have flow. If you don't have flow, and then this one times out. This is supposed to be normally closed. Sorry about that. It's supposed to be like this, okay? So you start, this is either at the time where the main drive delay timer is timing out to open this contact, you need to have flow so that 3BD4 is true and you seal in, okay? So that takes care of this whole thing. It's done, done, and done. In the next level, we'll talk about the pre-start warning sirens, okay? So insert, and then of course we're talking about 3BD1. Talking about 3BD1, normally open. So 3BD1 is going to be responsible for energizing the pre-start warning alarms, okay? And then 281 is the auxiliary contact for the power contactor of the crusher, the main drive. of the crusher. Okay, so when that power contactor is energized, its auxiliary contacts, okay, so 281, what I'm referring to is this one here. When 281 is energized, it's normally a closed auxiliary contact is going to open. Okay, when that normally closed auxiliary contact opens, the pre-start warnings are going to be de-energized. So the pre-start warning siren is on between the time that the sequence control relay is energized and off at the point where the power contactor for the main drive is energized. Okay, so normally closed. Again, when you talk about 281, okay, 281 is what? 281 is a feedback contact. Okay, so in as much as we're going to say 281, the right term would be 281 feedback. Okay, feedback contact, which I think we don't seem to have. Okay, symbol table. Let's see. So let's see 281. We went as far as memory bit 11.3. Okay, so we could have said insert symbol, and then we could have said 281 feedback. Okay, like so. Essentially, this would be power contactor, auxiliary, okay, power conductor auxiliary contact. Okay, so essentially what we're just saying is the power contactor for the main drive, the power contactor for that chi crusher. Now the main motor, when that power contactor is energized, its auxiliary contact is the one which saves us as a feedback. Okay, this would be important. This feedback would be important because now this is the one that would be used to do a whole lot of things. Okay, this would be used to de-energize the pre-start warning sirens. We've got one in the local station and one in the remote station. So let's see, pre-start warning siren, where they're labeled like this. So pre-start warning siren, local station. Okay, I think this one. Then pre-start warning siren, remote station. Okay, like so. Okay, so we'd have these. So the feedback is the one which would now de-energize the pre-start warning sirens, both in the local station and the remote station. So we have basically just taken care of this, as in represented by this one here. But the only other point is, in as much as we're sealing here, we're sealing 3BD1, you also need to bear in mind that 3BD1 was also responsible. The true state, when there's continuity, when we seal in 3BD1, right, at the point where 3BD1 is being sealed in, this timer here, the on delay timer, is also being energized. Okay, so to accomplish this, we can just as well do the following. Okay, we could just insert the network, and then we use the normally open contact. We use 3BD1. Okay, 3BD1, and then we insert an on delay timer. So we come to where they say timers here. Normal on delay timer, not the retentive one, but the normal on delay timer. And then this is going to be 3BD2. Okay, so let's see, 3BD2 as a timer, 3BD2 on delay timer, and I should think we need an output coil for 3BD2. So 3BD2, like so, right? That's what we had done, if I remember correctly. So that's how we accomplish this part. Okay, now comes the question to say, this is the loop control timer. It's basically an on delay timer, so we need to have a preset value, right? So 3BD2, when 3BD2 times out, its contact is the one which is responsible for this position here. Okay, so in as far as we are moving from left to right, we've made progress towards, we've done rung 3, 4, 5 and 6 and 7. Okay, the only thing we need to do is attach a time value. So S5T hash pre-start warning, the delay before the loop comes on. Okay, we can go for 10 seconds. Okay, after all, this is just simulation. So S5T hash 10 seconds. So basically the dead time between the time when the sequence control relay is energized, okay, when the sequence control relay is energized, at that instant the pre-start warning alarms in both the local station and the remote station will be active. Okay, but at that instant the loop pump will not be on, right? Because the lubrication pump needs a signal from 3BD2, this position here. It needs this to be true, and then when this is true, that's when the clutch timer is engaged, and that's when the clutch timer will bring in the lubrication pump. Okay, the on delay effect of energizing the clutch timer is being accomplished by this timer 3BD2, which is this timer here. And then when this timer times out, because it's an on delay timer, that 3BD2 normally open auxiliary contact is going to close there and energize the clutch timer, right? So we've done this. We're coming to this part here. Okay, so we move to the right. So insert a network. Now to accomplish this, we're not going to really worry about MC auxiliary. This is the main isolator auxiliary contact was used in this one, so that when you isolate the main you de-energize, or you put the main isolator in the off position, this auxiliary contact is also going to isolate the control for basically the loop and the main drive. Okay, so we move to the right. We're just going to focus on 4DD1. We're not even going to talk about 4DD1 or 3BD6 for obvious reasons, right? So the normal select and the test select. So the first position we'll choose is the normal select position. Okay, so we're going to get a normally open contact, and then we're going to say loop pump normal select. Okay, so we're past this position. Okay, and then we're talking about 3BD2. So 3BD2, we need this address here. Okay, as an on delay contact, so it needs to be open, and then paste this one here, and then of course, which brings us to this position right there. And then that's where we have the clutch timer, right? The clutch timer is essentially an off delay timer. An off delay timer. Okay, so this is an on delay timer. Now we need an off delay timer. So we need a timer which is an off delay timer, which is this one here. And then this is clutch timer. So let's see, was it labeled as a clutch timer 4DD3? Okay, meaning on the output side we need to associate this with 4DD3. Okay, I'm sure we explained why we're doing this. So an off delay, we could say, okay, the preset value in this case is said to be anything between 0 to 6 minutes, so we can choose any arbitrary value. So I'm going to just say S5T hash 30 seconds. Okay, like so. So this takes care of whatever this was. Okay, whatever this thing was is taken care of. What am I saying? 4DD3 off for 3BD2, so I need to control 4DC1. So we're saying normal select 3BD2 is on, and the clutch timer is. So basically what we're saying, so if this is energized, okay, energize instantly closes that. Okay, so at that point we have 4DD3, so the instant 3BD2 is energized. This off delay timer, the output will be true. Okay, the output will be true. So basically what we want is we can have another insert a network, and then we put a normally open contact. You can get this, paste there, and then on the output side we can say 4DC1. Okay, so like that. Okay, so that takes care of this part. Okay, that takes care of this part. And then what else do we need? Now you notice that to control this whole thing, right? To control, because the only thing we have done is we've just basically focused on how do we bring the loop pump on. Okay, so that's the only thing we've been telling ourselves. And then of course this is the whole sequence up to the point where 4DC1 is energized. We're saying when 4DD3 is true, then we just as well we could have just taken this and placed it there, neglecting the 4DD3, but I think it would be more convenient if we do it like this. Okay, because apart from that, we are talking about the test mode. Okay, we're talking about the test mode. So in the test mode, what's going to happen is 3BD6 is still going to be true. Okay, so basically we're not going to focus on that, but on this path in the test position we'll be talking about this one here. Okay, it won't go through 4DD3, so it's like the test push pattern is parallel to 4DD3. So essentially what we can just do is this, and then so we can say loop pump test push button. Okay, so that now we're able to achieve this path in the test. And then for this one, of course, you need to put the 3 position selector switch in the test position. Okay, so loop pump test select. Okay, like so. To access this path, you need to put the 3 position selector switch in the test position. Okay, loop pump test select, meaning the 3 position selector switch you put in the test position, and then can you press this button to control the lubrication pump, meaning you'll be coming through this path. Okay, you select 3 position selector switch needs to be in the test position. Okay, so that you come here and you have access to 4DC1, right? And then apart from that, what do we have? What do we have? You notice that whenever 4DC1 is energized, when this control relay or power contactor for the lubrication pump is energized, the auxiliary contact now is the one which has direct control over the main drive delay timer. So we're going to insert a network, and then basically just, again, I'm going to say this again, this is an external unit being controlled. Okay, it's basically a power contactor external. It's a physical thing which is being controlled. So to come and control this main drive delay timer, essentially what we need is a feedback contact of this power contactor designation 4DC1. Okay, so again we can come here, we can come to where there's 4DC1, right? We can come to this one here, and then we do this, we insert 4DC1, and then this we're going to call feedback. Okay, we're going to call feedback, so that now we have a normally open contact. Okay, we have a normally open contact. Did I copy it? So hopefully 4DC1 feedback, yes. So that 4DC1 feedback, this is not just any 4BDC, because when you're dealing with the PLC, you are trying to control 4DC1 is the power contactor for the lubrication pump. So the lubrication pump power contactor has got auxiliary contacts, and then that normally open auxiliary contact is being used as feedback to the PLC to just signal the system that yes, the lubrication pump has been energized, right? And if that's the one which is being used for feedback, it's now the one to control the timer, the main drive delay timer. So now insert an on delay timer. Okay, I hope it was labeled as main drive on delay timer for DD2. I bet yes. And then on the output side, did we declare 4DD2 as an output call? 4DD2, yes we did. And then the time for the crusher main drive motor to come on, we'll say S5T hash. Well, let's give it a petty 10 seconds. I'm just putting arbitrary values. You can these need to be the actual time values that you want your system to run on. So the main drive delay timer is being configured. So we've done this one here. Okay. We're not going to talk about the next run because we know it's just the protection side of things. But when we talk about the loop or pump running, you will notice that it depends on 4DC1. So for the loop pump running, this one as 4DH2, we need the feedback for the loop pump. Feedback for the loop pump. To 4DC1 feedback. So we need the 4DC1 feedback. This same feedback here. If we wanted, we could have just done this. Okay, then put an output core there, and then we could say 4DH2. Okay, could say 4DH2. So 4DH2 like so. Lubrication pump status running. Okay, because they both depend on the normally open auxiliary contact, but as we're saying, this has to be a feedback contact from the power contactor designation for DC1, which is responsible for energizing the lubrication pump. Okay, so there's that feedback thing. Okay, so this we have. Okay, so that's taken care of this, and then this was a level 1. This has been taken care of. This is now taken care of. Okay, now if you notice in this case we haven't even spoken about protection. Okay, so in this particular case, the only thing we need for the lubrication pump is level 1 protection. Okay, so what we're going to do is, you'll be saying, okay, at which point do we insert the level 2 protection? So level 2 protection affected the first rung, so this is already taken care of in this first network. So when we're talking about the loop, pre-start warning, 4DD3 clutch timer, of delay. So we'll be targeting, additionally we'll be targeting the clutch timer, right? Well, we start talking about the clutch timer 4DD3, seeing as how we're just trying to draw a parallel between the two systems, right? So how do we make the whole system collapse? When 4DD3 is de-energized, then this whole system collapses. Okay, because this is de-energized, then this one here. So clearly in one path, the normal state of level 1 protection is de-energized. Okay, so we could do this. Okay, we could do this. We could put a normally open, normally closed contact, and then we could say protection level 1, and then wouldn't really hate. We could also do this. May or may not be necessary, but that's just what we're doing, like this. And then here, protection level 1, because this path is protected by this part of the network, right? But not this other path. So here again, we can maybe put what? For DC1. How do we not make this much of a mess. Or maybe let's delete this, but rather maybe put it here. Okay, maybe let's put this here. This will take care of whatever mess happens. Okay, so like this, we're protected in both the test position and in the normal position. Okay, so the loop pump is only concerned with level 1 protection, not level 2 protection. Okay, so let's see. I think that's pretty much takes care of the loop. Okay, but the only other thing that we need to be mindful of is the existence of 3BD4, right? So 3BD4, I would assume this was what, 4DD2, the main drive delay timer. I would assume after the loop pump comes on, we would expect that is it flow, where they designated as flow 0101. Okay, then there's flow 0201. Okay, and then these will give rise to 3BD4. Okay, like this, and then that takes care of 3BD4. Okay, so now I think we're done with the lubrication system. Okay, but we need to be mindful that when we talk about 4DC1 feedback and 281 feedback, okay, when you talk about 281 feedback, we need to be mindful that we haven't designed an actual factory IO response to this feedback. I was just trying to tell you that ngamulela ndapadi feedback, or you're trying to control an external component or a power contactor. In this particular case, tulela ndati tulefwa ngatwachita control 4DC1, because 4DC1, like this 4DC1, ni power contactor ya lubrication pump. So when that power contactor is energized, we take its normally open auxiliary contact, which is going to be in the closed state in GABA energized. We run a signal back to the PLC, and that one will be 4DC1 feedback. Okay, when that signal is confirmed, only then does the main drive on delay timer 4DD2 become energized. At that point is also an indication that the lubrication pump status is running. Okay, when that is done, I don't know. What do we do? Do you think that maybe confirmation maybe happens afterwards? Okay, doesn't really matter, but I would rather maybe we put this flow network ballast here. Okay, so that seals in the lubrication pump behavior. Okay, so in the next run, or in the next network, we'll go to the main drive. Okay, the main drive, whatever is on the left, we've taken care of. We're just interested in the sequence. Okay, in the sequence, you see how we've simplified our lives. Okay, that's the only thing we need. Okay, munamo tulela ndati, there are two operational modes. Okay, from this point all the way up to this point, we're just talking about protection. Okay, so in this particular case, 3BD6 was level 1 protection, level 1. 3BD3 was level 2 protection. So maybe can't be too careful with these things. Okay, so closed to just be safe with our thing. So we can say protection level 1 and then protection level 2. But also this whole thing is dependent on that sequence relay. Okay, if the sequence relay has if you look at the sequence relay 3BD1 3BD1 in our case is this one here. Okay, 3BD1. 3BD1 already is dependent on the protection levels. Protection level 1, protection level 2. So 3BD1 is already protected. This 3BD1 here. Okay. So 3BD1, what it means is it's as good as saying 3BD1. Okay. 3BD1, the sequence control relay, because within the sequence control relay na ichita embed in ama protection levels yonse abiri. So nga twayisomu nombo we're saying 3BD1 is protecting the normal state. So what protects you? Okay, apa. So here there were two branches. This level of protection level 1, protection level 2, after it 3BD1. Okay? But in our system, because we need now two modes, I'm sure this is the test and this is the, because 284 is only actuated by the test, okay? And then uku normal. So we will depend on 3BD1 on the left, so that uku nombo tulandati normal. Okay, so normal select, so which is going to be main drive, normal select. Okay, so main drive normal select, main drive normal select, which is here. So through 3BD1, and you're saying that you need to determine 3BD4. Okay, so 3BD4 will be the flow that you need to confirm that there's a flow. Okay, so if you're saying that in the normal state, in both states, you also need to confirm or reaffirm the existence of the flow. But then again, if you think about it, what we said was in level 1 protection level 1, in protection level 1, if you remember correctly, when we spoke of protection level 1 was 3BD5. 3BD5 was a member of the protection level 1. Okay, 3BD4 was part of level 1 protection level 1. So even if we don't put it umu, so window here, okay, what I'm trying to say is at this point we're trying to make a note that in both operational states we need there to be flow, but we've said that in the operation of the lubrication pump, if there's no flow, by the time the main drive delay timer is timing out, then we're going to trip on level 1 protection, and level 1 protection is a part of 3BD1. Okay, so we're good for as long as we've got 3BD1 here, then everything is okay. So whatever this is, we'll just focus on 3BD1. So we are here. Okay, so 3BD1, we just depend on 3BD1. 3BD1 is both level 1 and level 2 protected, and then the only thing we need to do is normal select. Okay, so in normal select, and then we have the main drive delay timer, associated contact 4DD2. So maybe, okay, I can even put it here, and then this we're going to call 4DD2. Okay, like so. So we've got 4DD2. So anyway, maybe you'd want to see them in a flow type. Okay, so protection, normal select, 4DD2, and then thereafter we've got 281. Okay, we've got 281, like so. So 281 is this now, which is being designated as the main drive control. So this now is the one which controls the power contactor for the main drive. Once this is energized, the power contactor closes, the normally open auxiliary contacts close, the normally closed contacts, auxiliary contacts open, and whatnot. Okay, so this is how we've reached this far. This is just the normal state, right? But then you check to see that there's also what they're calling the test mode. Okay, in the test mode, of course, it goes without saying that there's protection involved. Okay, so we are protected, but in the test mode we're going to run through what they're calling this as 284. We could do without 284. What I mean is 284 is just going to be internally implemented, right? It's just going to be internally implemented. If it's going to be internally implemented, how do we reflect this? How do we reflect this? Okay, we could do the following. Okay, we do the following: signal protect. So anyway, I don't know what's because this here, it will be something like this. Okay, I've just copied the same network. What I'm saying is 3BD1 is protection, right? And then we're saying that this main drive, we're talking about test select. Okay, main drive test select will go like this, and then as a select and main drive test push button. Okay, main drive test push button, and then that will give rise to 284. Okay, this would give rise to 284. It will be something like this, just for us to have 284, right? So what we're going to do is going to do this. Okay, I'm sure this will just simplify our lives a lot better. Okay, so the only thing we need is 3BD6, 3BD3. We need both level 1 and level 2 protection, but level 1 and level 2 protection. Okay, so okay, let's see, protection level 1, and then now protection level 2. Okay, so with both protection, because I know 3BD6 is part of level 1 protection, and then 3BD3 is part of level 2 protection. Okay, these on top related to the main drive are part of level 2 protection. So basically what it is we need both level 1 protection and level 2 protection. So if both level 1 protection and level 2 protection are fine, and then if we are in the main drive test select, okay, main drive test select, and then only then can we use the main drive test push button. Okay, so let's copy this, paste there. We have control over that, and then we'll interlock these two networks. Okay, so here, where do we put this? Maybe here, normally closed. So we have main drive normal select, and then here main drive test select. Okay, so that these two events are mutually exclusive. Okay, main drive normal select, main drive test select. Okay, main drive test select, main drive normal select, main drive test select. So they'll be like this, in which case now we don't need this other one. Okay, so essentially what we're just saying is in the normal sequence we're going through 3BD1. Okay, yeah, but why are you using 3BD1? Because 3BD1 is supposed to be energized. Okay, when the sequence is starting, 3BD1 is supposed to be energized. What am I? Must be very tired now. So I'm thinking 3BD1 is normally open, actually, like so. Okay, so when 3BD1 is energized and then you're in the normal mode, then you come here. 4DD2 is the main drive delay timer, has timed out, it's going to be true. Then your power contactor for the main drive is going to be energized. But on the other hand, if you need to operate in the test select, then both protection levels have to be true, and then the normal the 3 position selector switch has to be in the test position. Okay, and then only then can you push the test push button. Okay, So that's what we have here. Okay, but there's another teeny weeny thing that I think we need to consider. Okay, we keep saying that we can't run the main drive if the loop station is not running. Okay, so if we come back to the loop, how do we operate this? We're not running through 3BD1. Okay, we're not running through 3BD1. So meaning, if you're going to work in the test mode, like you put the 3 position selector switch in the test position, like right about there, you're able to press this and you're able to start the crusher, but still the interlock is still available, which is 4DD2. That 4DD2 applies in both the normal state and the test select. So maybe this one here, 4DD2, can only come afterwards, after this. Okay, because 4DD2 applies in both instances. That the main drive delay timer, which was controlled by the lubrication pump feedback auxiliary contact. Okay, 4DC1 feedback is the one which controls 4DD2, like this one here, right? 4DC1 feedback controls 4DD2. So in this instance, when 4DD2 was timed out, only then can you press your test push button and you get to run. Okay, and in the same way, at this point, let's see. So test push button. So loop pump normal select, loop pump test select. The way this was, we could equally make these mutually exclusive. Okay, we could make these mutually exclusive like so. Okay, so we could make this mutually exclusive. I'm not doing anything, I'm just interlocking this so that the two events are always mutually exclusive. So protection 4DC1, if you're not coming through 4DD3, loop pump test select, then the push button 4DC1 feedback 4DD2. Okay, so what do we have here? Seems to me that for you to run the crusher in the test mode, you kind of like need 2 people to operate. Okay, because in this electrical schematic, once you press down the test mode here, once you press down the test mode loop pump motor, you're in the test mode. The 3 position selector switch is in the test position. You press down, 4DC1 is energized, and then 4DC1, the feedback controls 4DD2. At the time where 4DD2 is timing out, that's the point at which this is enabled. Okay, so at that point, if you are in the test mode, okay, if you're in the test mode, like if you're in this branch, okay, then you just get to press this push button. Okay, and then assuming the circuit is healthy, you're going to run through 284, and then you're going to energize the power contactor. So it's like the operation requires for there to be 2 people in this system. Okay, but do we need for there to be 2 people to operate? Anyway, considering the safety aspect of it, okay, considering the safety aspect of it and knowing that people can be funny sometimes, I think we'll leave it at this, that for you to operate, you need 2 people to put the system in the test position. Okay, because if you didn't want that, then what it would be is that How would we get out of this? Okay, so how do we get out of this? If all you care about is testing the lubrication pump, test multi-position selector switch in the test position, press down, 4DC1 is energized. As a consequence, 4DD2 is also energized. And if you wanted to test the main drive in the test mode, you could then do that, okay? Because then 4DD2 would have closed, and all it would take for you is to press this, okay? So to test this, you need two people to test, okay? So what if we needed just one person to test, okay? So what would say is the following, therefore. If we needed just one person to test the system, that the loop pump is okay, so in this aspect, what we would say is to test the loop pump by way of 4DC1, we're going to come here through this loop pump test, select, you select the test mode, and then lubrication pump normal select is not active, so that you just get to push the loop pump test push button, and then you get to test your loop pump, okay, by way of 4DC1. But 4DC1 brought in 4DD2, okay? So we're saying in that alternate path that if the loop pump main drive normal select, loop pump, no, main drive test select, main drive normal select, okay? So this path is all about testing the drive in the test mode. So let's modify this a bit. So if we say normally open contact, so loop pump test select, and then let's delete this. So loop pump test select, main drive test select, and then main drive test push button. You still need two people, okay? Okay, so how about if we got rid of the main drive test push button, okay? Okay, let's try this. Let's get rid of this main drive test push button, okay, like so. So we're saying we need both level 1 protection, level 2 protection, and the lubrication pump needs to be in the test select, okay? And then the main drive will also be in the test select, okay? So that once we get a permissive condition, we're able to test the main drive. This way we just need one person to test the operational state of both the lubrication system and the main drive system, okay? And then we're heavily protected. So that's the modification away from this, that we just need one person to test, okay? Not two people, but just one person. So let's run through our logic again. I'm not really concerned with this. 3BD2 lubrication pump control timer, which is an on delay timer for the loop pump. So 3BD1 281 feedback is the one which pushes out the restart warning siren. And then 3BD2, assuming the lubrication pump is in the normal select, then we'll have 3BD2 is true, clash timer as an off DT, so 4DD3 is going to be true, and 4DD3 is true, and then the only thing we'll need is this, okay? Maybe I'm not really comfortable with the way this is structured. Okay, I'm just going to rearrange this a bit, okay? I'm just going to rearrange this a bit. I would rather this becomes the first element. Okay, so maybe let's do this. What I'm trying to get at is this. Okay, I'm trying to get at, I'm not changing anything, I'm just rearranging. Okay, okay, so maybe something like this. It's the same thing, but just so clutch timer associated output 4DD3 is true. We protect 4DD3 is true. We get to energize the lubrication pump, and then in this other path we're still protected, level 1 protection, and then we're saying loop pump test select in the meaning that when the 3 position selector switch is in the test position, and then we press the test push button, loop pump test push button, we should be able to control the lubrication pump. And then thereafter we're saying when we get the feedback contact, then that's when we energize the on delay timer for the main drive. Okay, so when that times out, 4DD2 becomes true. So 4DD2 is now the one which gives a permissive condition for the main drive. Okay, but before that we're saying that since the loop pump is on, the loop pump has been energized by way of 4DC1, then there should be an expected flow. So when this flow is there, that 3BD4 will be true. 282. Okay, so 281 is for the main drive, but 282 is for the vibrator control interlock. And then I know it's written like this because 2AC1 is which one now? So 2AC1, 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 281. 281 auxiliary contact was responsible for 2AC1. 2AC1 was what? How do I put this? So 2AC1 was now responsible for whatever this is. 2AC2 is not described. So, but the only key takeaway from this is that there's what is being referred to as a vibrator control interlock. Okay, so basically 2AC1, this 2AC1 is this one here. It basically just increases the number of auxiliary contacts. Okay, so basically what it means is as opposed to doing what this 2AC1 business thing here to control, so it's dependent on 3BD1. Okay, so basically the only thing we can do is we can take 3BD1, put 3BD1 there, and then we're saying that we need to be in the normal select. Okay, so meaning you can't run the vibrators in test select. Okay, in main drive test select. Okay, so the main drive normal select, so main drive normal select. Okay, and then only then do you get a permissive signal for the vibrator control interlock by way of 282. Okay, so 282, this one here. So the only way you get to run these vibrators is if you are in the normal mode. Okay, the instant you get in the test mode, you won't be able to run the vibrators. But also it's dependent on level 1 and level 2 protection. Okay, but also you notice that 3BD1 is dependent on both level 1 and level 2 protection. So when 3BD1 as a sequence control relay is de-energized, then you do not have the permission to run the vibrators. Okay, so what else is there? 2AC1 or 3BD1, yes, 3BD1, and then main drive normal select, and then you need 281 feedback. Okay, so you need 281 feedback that the power contactor for the main drive has been energized. Okay, as a feedback messenger. Okay, so you energize 281. Okay, Part281, the main power contactor closes, and then you get a normally open auxiliary contact, wire it back to the PLC. It comes back as 281 feedback, so that you'll be dependent on three conditions for you to energize the vibrators. 3BD1 sequence control relay, which is dependent on level 1 and level 2 protection, and then of course that you need to be in the normal select, and then that you need to have feedback that the power contactor for the main drive has been energized, and then only then do you get to have the vibrators run. Okay, and then we had an indicator lamp to say crusher running. So again, so we can depend on the feedback. Okay, we can depend on this feedback to say this is what 2AH2. Okay, 2AH2, which is this one here that the crusher is running. Okay, so which takes care of that. And then for you to also be able to switch on this heater thing. Okay, so when there's feedback, so we can just do this and then do bit logic, negate, then do an output coil, assign it to heater on. Okay, did we have, oh yeah, right there, heater on. Okay, so essentially what I'm just saying is that if there's no feedback, the heater stays on. If there's feedback, true state, then after the negation, false state. Okay, true state, the indicator is on. So we've taken care of this, we've taken care of that, and then we're able to switch on or energize the crusher. Well, I think this pretty much covers most of it. If I've messed myself up, that will be brought to fruition. So that pretty much takes care of this. In the last step, we just do simulation.